Hello, everybody. So today we are reviewing factoring. If you haven't already, please put your name on your paper. I need to get my pen working. So let's see, Mrs. Pierce. This is either going to be 4th or 5th hour, and today's date is 16th, but you're going to be doing this on the 17th or the 18th. Hopefully the 17th, and you'll have it all done by the 18th. So anyway, we are reviewing factoring. There are 6 different types of factoring that we cover from integrated 2A. Factoring out the greatest common factor is one of them. Factoring out a basic trinomial, factoring the difference of 2 squares, factoring by grouping, and AC method. So we've got lots of examples there. We're going to start out with the greatest common factor. So when you're looking at a polynomial, you look at all the terms and ask yourself, looking at the coefficients, what's the largest number that you can divide out of all 3 of those numbers, 15, 36, and 6. So the greatest common factor, like I said, GCF stands for greatest common factor. GCF, which again, I said the 3 is the largest number that you can divide out of all 3 of these terms. But then you also want to look at the variables. So as far as the variables, they all have an x. This one has an x to the 3rd, which means there are 3 factors of x in it. This one has an x to the 4th. This one has an x to the 5th. Since you cannot take out more factors than one of the terms has, x to the 3rd will be the largest amount of x's that we can factor out. So the greatest common factor then is 3x to the 3rd. Since there are 3 terms in our trinomial to begin with, our polynomial, there will also be 3 terms inside the parentheses after we've factored out that 3x to the 3rd. And so factoring is kind of like unmultiplying or undistributing. So the 3 that we're factoring out is being divided from all of these numbers, and same with the x to the 3rd. So what's going to be left here is what you get when you divide 15 by 3, which is 5. X to the 5th divided by x to the 3rd is x squared. When you divide 36 by 3, you get positive 12. And then x to the 4th divided by x to the 3rd is x. Negative 6 divided by 3 is negative 2. And then the x to the 3rd, we already factored out that x to the 3rd, so there are no more x's to be put with that too. Now, one trick to making sure that you've factored out the greatest common factor correctly is, number 1, if you were to multiply these terms back together, so the 3x to the 3rd times 15x squared, it should equal the 15x to the 5th that you started with. The 3x to the 3rd times 12x would be 36x to the 4th, and the 3x to the 3rd times the negative 2 would be negative 6x to the 3rd. The next thing that you want to ask yourself is there anything else that all 3 of these terms in the parentheses have in common that you could factor out? So 5, 12, and 2, no, the only common factor between them is 1. And you've got your x squared x here, but there are no more x's in the 3rd term, so they do not have any more common variables either. As we get later on into some more difficult factoring, you will also have to sometimes factor the trinomial that is left inside of the parentheses. However, if I can tell by looking at this cannot be factored. So this problem is factored completely. So I'm going to put a box around my answer to show that that is done. Okay, so now we're going to go to the next example. I'm going to pick a different color. So the next example, I have 2 terms, although they're really not in the right order. So if I were to rewrite this in the proper order, the negative 30x to the 7th would go first. And then the 18, which is positive, would go next, x to the 5th. Now, whenever you're factoring, you always want to factor out leading coefficient that's negative. So even if it's just -1, like in the next example, we're going to have to factor out a negative. You never want your leading coefficient to be negative, but you don't disappear. It doesn't disappear when you're factoring it out. It just kind of goes out front. So besides the negative, we also want to look at the 30 and the 18 and figure out what's the largest number you can divide both of those by. And hopefully you would think of 6. And then the x to the 5th is also the most x's that you can take out, because this has five factors of x and this one has 7. So you cannot take out more than 5. All right, so since, again, this had 2 terms to begin with, in the parentheses, you should have 2 terms. Then you're dividing the -30 by -6, will leave you with 5. The x to the 7th divided by x to the 5th is x squared. Oops. Okay, that didn't turn out real good. Let me try to erase that and do that again. There we go. And then the 18 divided by the -6 is -3. X to the 5th, we took them all out, so there won't be any more x's. And so now this is completely factored. All right, the next one, again, like I was saying, there are 2 terms, but there's a negative in front. Different color. And it's basically a -1 here. We do need to factor out the negative, but there aren't any common numbers or factors of 1 and 6 that you can factor out other than 1, but we really never factor out 1. Well, in certain situations, but they do both have an x, so I will factor out a -x. Again, since there are 2 terms here to begin with, there should be 2 terms in the binomial when you're done. So if I factor out a -x, I ask myself, well, -x times what would equal -x squared? And that would be another x. Now be careful here, if you're factoring out a negative from a positive, this will end up being a negative. And then since we factored out the x, we still have the 6 here. And then what you have left in parentheses cannot be factored any further. So we just factored that out. So these are 3 examples of factoring out the greatest common factor. The next type of problem types of problem is factoring a basic trinomial. So a basic trinomial basically has a basic trinomial is going to be 3 terms, 1, 2, 3, but the leading coefficient is 1. So A is what we call the leading coefficient, and it is 1. So if you look at all of these trinomials, you have r squared and r and then a constant, and x squared and x and a constant, d squared, d and a constant. So the first 2 examples have a leading coefficient of 1, but the third one here is a leading coefficient of -1, which we will have to factor out when we get to that problem. So factoring basic trinomials is one thing that we do a lot. So you're trying to figure out what 2 linear binomials would multiply together to equal this trinomial. So there are a couple ways that you can do this. You could make a table of or a list of all the factors of 63. So if I were to list the factors of 63, I would have 1 and 63, 2 does not go into it, 3 and 21, 4 does not go into it, 5, 6, no, 7, yes, 7 and 9, 8, no, and then since 9 is already in the list, I now know I have all the factors of 63 present here. So then I want to, I don't know how this blue thing got here. Okay. So I guess I highlighted that. So next we want to figure out what 2 numbers multiply. And some of you have learned this X thing here, where you put your C up here and your B value down there. So C is the 63, B is the 2. So we've got a negative 63, and then your b value is a positive 2. So you have to be careful. You're looking for two numbers that multiply together to equal 63, but because it's negative, the two numbers have to have opposite signs. One's going to have to be negative, and one is going to have to be positive. And not only do these numbers have to multiply together to equal 63, but they also, when you include the signs, have to add up to positive 2. So when signs are different, a lot of times you need to find numbers that have a difference of, say, 2. So if you look at the 7 and 9 here, 7 and 9 have a difference of 2. They also multiply together to equal 63. If I have a positive 9 and a negative 7, then that will multiply together to equal negative 63, but also add up to positive 2. So the negative 7 and 9 are the numbers that are going to be used to factor this trinomial. So this trinomial factors into two binomials. The term here and here have to multiply together to equal the r squared. So r times r will be the r squared. And then the two numbers that we found, the negative 7 and the positive 9, are going to complete those binomials, linear binomials. And again, if you were to multiply this back together and distribute the r to the r, you would get r squared. R times positive 9 would be positive 9r. In the inside, you would have negative 7 times r, which is negative 7r, which together would be a positive 2r, and then negative 7 times 9 would be negative 63. So I checked my answer, and those are the factors of that trinomial. Now, some of you may have originally learned to factor these basic trinomials with the AC method, where you take your three terms and you turn them into 4. So I'm just going to show that down here. Although with basic trinomials, I really don't want you to be using the AC method all the time. It is really a waste of time when you have to factor a lot of things at once. And as you get more comfortable with factoring, you should be able to factor these things in one step. But so method 2 here, the AC method, if I take the same trinomial and rewrite this as 4 terms, so it's kind of like the undistributing of this. Your r squared would be your first term stays the same and your last term stays the same. And then in order to get this 2r, the positive 2r that we have in the middle, you're still going to need those same two numbers, negative 7 and positive 9. And it doesn't really matter what order you put them in. So let's say I put positive 9r first and then negative 7r. Well, now it's a matter of factoring by grouping, which we haven't quite gotten to yet. But when you're factoring by grouping, you kind of look at the two groups here. Change my color. And you kind of separate the first two terms from the second two terms. And the first two terms here, where'd my cursor go? There you are. My first two terms have a common factor of r. So I would factor that out. And I would then have r plus 9 in parentheses. And then my second two terms have a factor of negative 7, which gives me r plus 9. And then again, if I think of this as one term and think of this as another term, they have a common factor of r plus 9. So when you're factoring by grouping, you're actually factoring out a binomial. So I'm taking out the factor of r plus 9 from both groups. And then the r minus 7 is what's left. And if you notice that this answer is exactly the same as we had up here earlier, but we had these additional extra steps that take a lot of time. So with basic trinomials, you really want to be able to go from one step to another. So anyway, that's how I'm going to do the rest of these. Let's speed this up a little bit. All right, let's use orange this time. So now we have a basic trinomial again, but this time the constant c is positive and your b is negative. So as you're trying to factor this, you're trying to find two numbers that multiply together to equal a positive 10, but will add up to a negative 7. So 10 itself has factors of 1 and 10 and 2 and 5. So in order to get a positive here, you must have the same signs. Oops, I clicked on something here. I don't know how to undo that. Okay. That's not going to work. Oh, there we go. All right. So we are going to have the same signs. In our two binomials. But in order for them to add up to a negative 7, they must both be negative. So a negative 2 and a negative 5 will work because negative 2 times negative 5 multiplies together to equal positive 10, but then they'll add up to a negative 7. Now your variable here is x squared, so x times x. And then, like we said, our two numbers are negative 2 and negative 5. And now we have factored this completely. Next problem. So let's take choices. For the brown. All right, so this next one here, we have, again, a trinomial, but your leading coefficient is not 1. It is negative 1, which means we need to factor out that negative 1. When you factor out a negative 1, you're still going to have 3 terms like we started with, but all the signs are going to change. So when we factor out a negative 1, the d squared becomes positive. This positive 20 becomes negative 20, and the negative 100 becomes a positive 100. And then we kind of go through the same scenario again. What two numbers multiply together to equal 100? But now our sign is positive. So again, our signs have to be the same. They're both going to be negative. So we're looking for two numbers that multiply together to equal 10 that add up to 20. So hopefully all of you are thinking that 10 times 10 multiplies together to equal 100, but also adds up to 20. But again, the signs have to be the same. They both have to be negative so that they will multiply together to equal or add up to that negative 20. Don't forget about the negative 1 that you have out front. That is also a factor of the original polynomial. And again, if you like to see it up here, you've got your positive 100 and your negative 20. So negative 10 and negative 10 will multiply. They multiply together to equal 100, but they add up to negative 20. And that's where we get these two numbers from. Okay, so the next type of problem is your difference of two squares. And the rule with difference of two squares is basically if you multiply, well, the formula, a squared minus b squared will factor into a plus b and a minus b. So where a is basically the square root of the first term, b is the square root of the second term. Because it's negative, your signs are opposite, and there's no middle term because the middle term would cancel out if we were to multiply it back together. Again, you want your leading coefficient to be positive, so this second example B, we're going to have to factor out that negative. But example A is just a pretty basic one. You've got a perfect square, x squared, minus 64, which is also a perfect square. So it will factor into two binomials. Your x squared factors into x and x. The square root of 64 is 8. And then to get a negative 64 in there, you need a positive and a negative. And that's how you factor a difference of squares. If you have a negative in front, you again want to factor out the -1, which is going to change your signs. So the x squared becomes positive, the +1 becomes negative. And then now we have a difference of 2 squares. So a difference of 2 squares, you must have a minus sign in between. So this x squared minus 1, the x squared factors in x and x. Now, some students always forget that 1 is a perfect square. The square root of 1 is 1 itself. So we can put 1 in for both of those. In order to get a -1, you have to have a 1 positive, a 1 negative. That's factored completely now. And we'll do one more of these that has a little bit more difficulty. You've got 2 variables and 2 coefficients that are both perfect squares, but you still have that negative in between 2 perfect squares, which does mean it is a difference of squares. So let's see. Oops. That's how I can move this over. Okay, maybe not. Okay, so we are going to factor this again into 2 binomials. When you're taking the square root of each term, 49 is a perfect square. The square root of it is 7. Since you have a r squared, you also need to put r with that. Your 36 is a perfect square. That factors into 6 and 6, but make sure you leave a little bit of room because you've also got this s squared. So 6 times 6 is going to equal 36, but not 36s squared. So you do need to leave a little space for the s in there. That doesn't look like an s. There we go. A little better. And then again, your signs have to be different. It doesn't matter which one you put first, but as long as one is positive and one is negative. And that's factored completely now. All right, so factoring by grouping, we kind of already did one example of that when we were showing this example up here. But sometimes you factor by grouping when there are 4 terms, and again, you always want to look for common factors, but I don't believe any of these have any common factors off the bat. I try to keep them simple at first. So when you're factoring by grouping, you do not have any common factors in any of the 4 terms. But since there are 4 terms, you could possibly factor by grouping. There are times where you cannot factor by grouping, and there are other methods of factoring that for 4 terms. But these examples here, we're going to show you how to factor by grouping. So you've got 4 terms, and you want these to be in standard form. You want to split these into 2 groups, and I just like to put a little line between them, but make sure that the sign, you're not crossing the sign of the 3rd term, because that 3rd term, the sign is very important. So yeah, this sign here is very important. So if we just look at the first 2 terms and ask ourselves, what can we factor out of those first 2 terms? Well, they both can be divided by 5. They also both have g squared in them. So I'm going to factor out a 5g squared. Since there are 2 terms here, there should be 2 terms here. When I divide the 20 by 5, I get 4. When I factor the g squared out of the g to the 3rd, I get another g. And then the 15 divided by 5 is a positive 3. And then I factored out the g squared already. So, and if you were to mentally multiply this back together, it should equal what you started with. All right, now we'll move on to the next 2. So whatever this 3rd sign is, should be the sign that you bring down here. And then again, looking at these 2 terms, what can you divide out of both of those terms? They can both be factored out. You can divide out a 2. But now because you're dividing out or factoring out a -2, again, your signs are going to change. There are 2 terms here. So there will be, since there are 2 terms here, there are going to be 2 terms here. If you divide the -8 by -2, you get a positive 4. The g is not being factored out because the 6 does not have a g, so that would stay there. But since you're dividing -6 by -2, you're going to get a positive 3. And now, hopefully you'll notice that we have two binomials here that are the same. Same number, same sign, same everything, which is what you want when you are factoring by grouping. So look at this. Think of this as one term. Think of this now as one term. And if you ask yourself, what do these two terms have in common? You would say the 4g plus 3. So what you're actually doing is factoring out the binomial 4g plus 3. And then when you factor that binomial out, you still have a 5g squared minus 2. So for this problem, we have now factored it completely. All right, let's try the next one. If you want, you can try the next one on your own and then fast forward the answers. But again, I've got 4 terms. I'm going to split it down the middle, factor what the first 2 terms have in common, and that is your x squared. Since I have 2 terms to begin with, I will have 2 terms in the parentheses. When I factor out the x squared, I will be left with an x. When I factor out this x squared, I still have a minus 7. All right, so that group is done for right now. Again, this sign is brought down. And then looking at these 2 terms, ask yourself, what can I factor out of both of those numbers? A 9 can be factored out of both of those numbers. Again, since there are 2 terms here, there should be 2 terms here. So when I divide the first term by 9, I still have an x. When you divide the second one by 9, you get a negative 7. And then once again, you will notice that you have in this group, you have an x minus 7, and in this group, you have an x minus 7. So you're factoring out the x minus 7. And then when you factor out the x minus 7, you have the x squared plus 9 left in the other parentheses. And if you were to go through back and kind of mentally multiply this back together, the x times the x squared does equal the x to the third. X times 9 equals the 9x here. The negative 7 times x squared would be negative 7x squared there. Negative 7 times 9 is negative 63. And then one other thing, if this had been a minus sign instead of a plus, then we could have factored this out a little bit more, which I believe the next example is going to show. But you cannot factor a sum of 2 squares with real numbers. So this is factored completely. All right, so in my next example, again, I have 4 terms. I'm going to split the first 2 terms from the second 2 terms. Ask myself, what can I factor out of these first 2 terms? An x squared. And then when I factor out an x squared from both of those terms, I'll have x plus 4 in parentheses. The next 2 terms, I can factor out a negative 49. And I know that seems kind of like a big number, but at the same time, think about what you're trying to get. If you have an x plus 4 here, you need to get an x plus 4 here. And the only way that's going to happen is if this negative 49 gets factored out. So it just so happens that if we do factor out the negative 49 from the negative 196, that will equal a positive 4, because negative 196 divided by negative 49 is positive 4. So then again, we think of this as one group, think of this as one group. And if we look at the 2 groups, they have the x plus 4 in common. So we're going to factor that out. Once we factor out the x plus 4, we still have the x squared minus 49 to put together. And then this is one of those special problems where you can actually factor it a little bit more. The x squared minus 49 is a difference of squares. and it can be factored into x plus 7 and x minus 7. And don't forget about the x plus 4 that you factored out in the beginning. That has to be, that's one of the factors in your answer. Okay, so now moving on to the AC method. I'm going to pause and probably create another